So basically the pattern that we're going to use to draw these reciprocal functions is that when we have a zero value for the f of x, the 1 over f of x function is going to have an undefined value there, and we're going to end up with vertical asymptotes. We're going to have vertical asymptotes at that spot. And the other pattern is, as the original graph goes towards 0, that graph is going to go up to infinity or go away from 0. As this graph goes up towards infinity, this graph is going to go down towards 0. So it's going to behave in a reciprocal manner. And same is going to happen on this side. We just have to make sure that we keep the positive y values on the positive side of the x-axis. And we have the negative y values here have to stay on the negative side of x-axis. So using that same concept then, we're going to take a look at where the graph hits 0. That's going to be our key point. When the graph hits 0, we know the reciprocal graph is going to have a vertical asymptote. And as the graph goes away from 0, here the reciprocal graph is going to go towards 0. And the invariant point happens when x equals -1 and +1, because the reciprocal of 1 and -1 is itself. This graph's going to go towards 0, so the reciprocal graph goes away from 0. And since it's negative, it's going to stay on the negative side. Here it's going to be mirrored. There's what we call our invariant point. It's going to go towards the x-axis. This is going to go up the asymptote. In between here, we're on the positive side, and there is a vertex. So that vertex of y equals 3 becomes a vertex of 1/3. And the same thing happens. As it goes towards the x, there's our invariant points here and here at y equals 1 and -1. It's going to go down to the vertex and then go up along the asymptotes. So as this graph goes towards 0, the reciprocal graph goes up to infinity, because essentially we're dividing by 0. It's going to go bigger and bigger. Okay, we're dividing by 0 from the negative side. It's going to go down towards negative infinity. So these are the key points then. We have our zeros give us our vertical asymptotes. The pattern is the black graph goes away, the reciprocal graph goes towards the x-axis, and vice versa. The other points that we talked about here in this example was the invariant points. These are when y equals 1 and y equals -1. That's where the two graphs would cross, and then this vertex will show up as a vertex, and we can just take the reciprocal y coordinate to figure out exactly where that vertex is going to be. So here we've been given the reciprocal function, and we're just going to find the original function. So I'm just going to sketch the reciprocal function. Okay, at x equals -4, y equals -1/2, x is -3, y is -1. At -2, we have an undefined value, so that's going to be a vertical asymptote. At -1, it's equal to 1. And at 0, it's equal to 1/2. So it's going to tend towards the asymptote here, and it's going to tend towards 0. Okay, so my invariant point is at -1 and +1 here. These big red dots will represent the invariant points, and it's going to do the same thing here. So then to plot the original function, we just take the reciprocal values. The reciprocal of -1/2 is -2. Again, make sure that you keep the signs on the y values. -1, the invariant point, an undefined value. If we take the reciprocal of that, it's equal to 0, 1, and 2. And so we can just plot those coordinates through our invariant points, and we can see that this is a linear function that goes through there like that. Okay, and we have a y-intercept, a slope of 1 with a y-intercept of 2.